everybody, Mrs. Slauson. So we are doing our final set of notes for Chapter 2, and we are technically on the very last page. But before I start there, I think it might make this section a little bit easier if we look at something that we've already done to see that what we're about to do is not much different from things that we've done in the past. So I'm actually on page 6 in your note packet. These were some problems I had asked you to take a look at as for practice. While we're still in the hybrid mode. And so I'm just going to pick a few of these problems and go over them. I'm also going to pick them because when we do offer the retakes for the Chapter 1 test, which will be after Thanksgiving break for everyone, we've decided, these are things that will play into it. So I'm just going to pick 2 of these problems, go into them, and then let you go from there. So first of all, this is just about evaluating functions. So the ones I want to take a look at, for instance, are going to be, let's take a look at C, and let's take a look at D. So looking at C, the idea is I have a function, and they want me to put -4 in for x. So first of all, since my function is f of x, I'm going to be using this function. And then when I have to choose where to put that -4, I'm going to put it in this one, because -4 fits this domain. -4 is less than -3. So I'm going to put that in there. And again, I'm choosing this problem in particular because of our Chapter 1 retake. And so you don't distribute. These aren't parentheses. These are absolute value bars. So my goal is to get the numbers inside the bar down to 1 value. So if I have -4 and I take away 3, that turns into -7, still in the bars. And then what you need to remember is that when you take the absolute value of a number, it always forces it to become positive. So that -7 becomes a 7. And now I can multiply it by the 2. I'll multiply, add them up, and so when I'm done, I get 15. All right? So let's take a look. Let's do one more. Let's just choose this function. So this is f of 1, so I'm going to go back to this function. And when I have to choose which one to use, x being 1 fits into this domain because 1 is greater than or equal to -3, so I'm going to put -1 into here. So there's the negative that's outside of the x squared, and then I'll be taking -1, squaring it, and then adding 8. So again, I'm just going to follow my order of operations, which says I should take -1 and square it first, so that gives me 1. And then this negative says actually take the opposite of 1, which is -1. Add the 8, and when I'm done, I get 7. So again, this is something that you saw in freshman year. You maybe saw a little bit in geometry, probably not that much though. And then again in Algebra 2. So the last one I want to do with you is h with x plus 2. So because I'm working with the function h, I'm going to be moving to over here. And in before, I was putting a value in for x, but this time I'm actually going to put all of x plus 2 in for x. So all of this is going in right there. So it's going to be x plus 2, and instead of x being squared, now it's x plus 2 squared. And then I'll subtract the 7. And now I'm going to simplify this by just realizing that that x plus 2 squared means there's 2 of them. This is a neighbors meet the neighbors situation. We're just going to distribute. So I'll get x squared, 2x, and then I'll get another 2x, and then I'll multiply those for 4. I'll bring in that subtracting 7. So that when I'm done, I have x squared plus 4x, and then I'll subtract those and have -3. So the idea of this is what's going to play into our final section. So now what I want you to do is jump to the very last page of your notes. I think it's the last page. Let me double check that. Not quite the last page. I take that back. Page 39 in your notes. And we're going to finish up with operations of functions. So what we've already looked at is adding functions together, subtracting them, multiplying. There is division, but we're going to save division for a later chapter, even though they are in these notes. And we're going to do the final operation, which are called composition functions. And a composition function is just when you have 2 functions and you take one of the functions and you substitute it into the other, which is what we just did. So again, how do you already know this? Well, I have my function, f of x, it's 3x squared. And this says I should take the 4 and put it in for the x. So I'm going to do that. So it's normally 3 times x squared, but now it's going to be 3 times 4 squared. I'll follow my order of operations, so I'll multiply, or I'm sorry, do exponents first, and then I get 48. So now, again, we already know this, we just practiced it. So again, I still have the same function, but now instead of putting 4 into the function, I know that's a little blurry, I'm going to be putting x minus 4 into it instead. So normally it's 3 times x squared. Well, x minus 4 is going to go in place for the x. And I'm going to simplify this by recognizing that x minus 4 squared means there's 2 of these. And then I'll have the neighbors meet the neighbors. Again, I always choose to have the parentheses multiply first. So I'm going to get an x squared minus 4x. And then I'll have another minus 4x, which when I combine it to this will actually turn it into minus 8x. So I'm going to go ahead and just do that. And then when these multiply, I get 16. And I still don't want to forget about the 3 that wants to multiply in there. So now the 3 will go in there like so, and I'll get 3x squared minus 24x plus 48. And so this is my final answer. And it's this idea here that plays into composite functions. So we have 2 functions, f of x and g of x. And what I'm going to do is, if you notice there's lots of parentheses here, I'm just going to make those outer parentheses stand out just a little bit more. And so what this says is where 4 went into f and x minus 4 went into f's function. Now what this means is all of g of x will go into f's function. So what I'm going to do is take a look at what g of x is worth, and it's just worth this x cubed. So just moving down, there's the f, and instead of g of x, I'll put the x cubed in, because that's what g of x is worth. And now this x cubed, just like the 4 went in there, and the x minus 4 in there went in there. Now x cubed is going to go right in there. So normally it's 2 times x squared. Well, in for x is going to go this x cubed. And now that's squared. And again, that squared just means there's 2 of these x cubed. So I'm going to multiply that out. And then this becomes x to the 6th, and then it becomes 2x to the 6th. So when I'm done, I have 2x to the 6th as my final answer. So let's try it again. Let's go to this one. So again, I have 2 functions. I have g of x and f of x. Similar, but this one's a little different. And again, I'm going to make these outer parentheses stand out. So this says take f of x and put it into g of x function. So what I'm going to do is take f of x and what it's worth and just put it into here. So it looks a little more familiar. And then all of this is going to go right where that x is. So it's going to be 2, and then instead of x being squared, all of this will be squared. And again, that x plus 3 squared just means there's 2 of these. And so I have a lot of neighbors meeting. I like to start with the parentheses, and I get x squared. And then I get a 3x, but then I get another 3x, and those 2 3x's will make a 6x. So this is, whoops, that's x squared. And now I have a 6x, and when I multiply 3 and 3, I get 9. And then I don't want to forget the 2. So now the 2 is going to distribute into everything. And I realize I'm running out of room, so I'm going to stick my final answer right here. So when the 2 distributes, I get 2x squared, I get 12x, and I get 18. And that's what a composite function is. So it just looks a little different, but it's something that you already know. So let's take a look at 2 where we're evaluating actually evaluating a value, more like this problem. Okay? So when I look, and I realize I cut this off a little bit, again, I'm just going to make these outer parentheses start out a little different. So there's a different way you could do this, but I'm going to show you what I think is probably the easiest. So if you envision a table, sometimes tables have lots of silverware on them. I want you, when you see this number in there, to imagine that when you have lots of silverware, you always start out with the outer set, and then you work your way in. So that's what we're going to do, is we're going to start with the outer parentheses and just focus on what's inside of there. So this says take 2 and put it into g's function. You might hear my dogs barking back there. So, okay, so we had to pause and get the dogs outside. So anyway, I'm focusing on what's inside these outer parentheses, and we're going back to what we already know. This says I have my function g of x, right here, and this says just put 2 in there. So I'm going to go ahead and do that. So starting here, just this part, in for x will go the 2, and I'll do 2 cubed, and that becomes 8. So g of 2 is actually worth 8. So now what I'm going to do is just replace this g of 2 with that 8, like so. And then the f comes down, and now I have another function to evaluate, and this just says, all right, go to the f of x function here and put 8 in for x. So that's what I'm going to do now. So it's 2 times 8 squared, and again, just follow your order of operations. You should do your exponents first. That's 64, and then 64 times 2 is 128, and that's my final answer. So let's do the second one, and then we're going to be done with the video notes. So again, when I'm evaluating an actual number, a value, again, I'm going to take these outer parentheses, just make them stand out a little bit more, and I'm going to go to this function, and I'm going to take f of x, and this says put -2 in for x. So it's going to go right there. So I'm just going to write that below. It'll be -2 plus 3, and that turns into 1. So when you're done, f of -2 is actually worth 1. And then I'm going to put the g that was there. And now this says go to g of x and put 1 in for x. So I'll do that now. So normally 2 times x squared is now 2 times 1 squared. Again, I'll do my exponent first. That's 1. And 1 times 2 is 2. And there's my final answer for g of f of -2. So again, how do you say this? This is f of g of x. This means g is going to go into f's function. And you say this as g of f of x, and this means f is going to go into g's function. And that's it for your notes.